Welcome to episode 4 of AU Manufacturing Conversations with Brent Belinsky. This time around we look at pyrolysis with John Mellows, the director at PyroAg and Biocarbon. We've occasionally written about biochar in the past. It's a subject that seemed to have a false start in Australia a little over a decade ago and hasn't yet taken farms or carbon trading markets by storm. Maybe one day it will play a role in large-scale sequestration of CO2, but right now it's apparently stuck in a classic chicken-egg scenario. Too costly because there is not enough demand because it is too costly. We talked to John about making biochar, as well as the potential of wood vinegar, which PyroAg makes and which is another product of pyrolyzing biomass. PyroAg has worked with University of Newcastle researchers over the last few years on wood vinegar to understand its safeness and possible benefits for farmers. We also get an update on Biocarbon's work creating and incorporating biochar briquettes in electric arc furnace steelmaking with Molycop. Thanks for downloading this episode. If you enjoy the conversation, please subscribe, leave a review via the podcast platform of your choice, and help us spread the word. Good afternoon, John. Thanks for joining us on AU Manufacturing Conversations.
Oh, it's great to be here. I've never been interviewed before, mate, so do be gentle.
I'll do my best. Tell me about yourself, John. This is the first time we've spoken, and I'd like to know a little bit, please, about how you got here and what you make.
Well, okay. Do cut me off when I get boring, because that's if I talk about myself, it's bound to happen. So I trained and worked as a civil engineer for many years, with a bit of time in wastewater treatment, in which, funnily enough, microbes are used to clean up the water. This formed the foundation of my knowledge of soil microbes, which PyroAg cuts into. I also worked in road construction, mobile phone infrastructure, a couple of other things where I learned from some really good people, excellent engineers and project managers. We've got a great resource of great people out there in Australia. We should never forget that. Mm-hmm. Since then, I've been running a medium-sized metal fabrication business and machining shop, Northside Fabrications and Dowtex Industries. I was doing that for a couple of years, and my schoolmate, a good schoolmate and business partner, Chad Shepherd, sold a marine business, and I just couldn't stand the thought of him retiring before me, so I hassled him to do something together. And we started looking at alternative energy technologies. The one that really caught our eye was pyrolysis of biomass, which produces, clean burning gas, charcoal, sometimes called biochar, and pyroligneous acid from biomass, which you put in the front end. We researched the use of the pyroligneous acid because we sort of wondered what this stuff was and what you could use it for, and found that it's been used widely in Southeast Asia and Japan for a couple of centuries now, probably more like 3 actually. So we bought some on the internet from, I think Chad got it from Japan perhaps, and we tried it on some pot trials and found that it did make those plants grow faster and bigger and healthier. So we thought, this is interesting. So we produced our own pyroligneous acid, or wood vinegar, named it PyroAg, in a little pilot plant we've built ourselves. And we also import a little bit to just to keep up with the demand, because it's hard to match the sort of demand and production cycles at times. We've been working closely with our dealers, particularly a guy named John Norton from Biotech Organics in South Australia, just to ensure that the product is of a consistent quality, because wood vinegar can be made, well, there are many variables in the production of it, particularly temperature and time at temperature. And these can give you very varied results on the product. So we've had to really work to ensure that what we put out is a consistent quality, just to make sure that people are getting the same thing they got the last time they bought it.
We've mentioned some words that might be not 100% familiar to some people. Could we just quickly have a sort of a bit of a glossary section where we talk about what pyrolysis is, what biochar is, what syngas and wood vinegar each are? If you're able to just tell people who might not know a hell of a lot about any of those terms, what they mean.
Sure, that's a good idea. It's a bit of a minefield of new jargon for people who haven't heard this stuff before. Sure. So pyrolysis is quite an old technology, but basically it's the heating of any organic or carbonaceous material to relatively high temperatures, sort of around 600 degrees, with very low levels or no oxygen in there. For those who know anything about combustion, it's the oxygen that makes the thing burn. So without the oxygen, you're really just cooking the material or heating it enough so it breaks down into the base elements such as carbon and hydrogen and nitrogen and whatever else. Then those things reform into things that you might want: methane, gas, hydrogen, water, and in our case, a variety of organic acids and phenols. The carbon, most of the carbon then gets left behind, and this is the charcoal or biochar, as people call it.
Mm-hmm.
As I said, pyrolysis is an old technology, very common prior to the petroleum industry coming along. Is a way of getting your hands on a lot of industrial chemicals. In fact, I grew up next to a demolished plant at Manly,
mm-hmm.
which got knocked down in the late 60s, I think. Biochar is just a charred material, as I said, that gets left behind once everything else has been cooked off. It can be added to the soil to improve the soil properties. It's got lots of little tiny holes in it,
mm-hmm.
lots of pores. And I like to think of it like a block of flats for microbes to live in.
Right.
And that's how it helps the soil. You've got lots of microbes in there, and also it can hold water, nutrients, etc. It's a structural additive to the soil. It has no fertilising properties as such, but it makes the soil structure better, if you can imagine that. Biomass is any material that's basically come from living things, such as wood chips or nutshells or whatever. It's a massive resource that's relatively untapped at the moment, often burnt or tipped into landfill, and syngas is formed in that pyrolysis process and is a blend of all the pyrolysis products that are gassed at normal temperatures, such as the methane, the hydrogen, the CO2 and so on. It doesn't really have a high energy density like natural gas or LPG,
mm-hmm.
so it's not necessarily worthwhile compressing and storing, but if you've got heat requirements on the site, it can put a big dent in your energy bill, as you can imagine. Like a lot of the places we're talking to about going, they use a lot of energy to dry nuts or season timber or what have you. So that gas can find a good home there. Wood vinegar or pyroligneous acid is the stuff that is a liquid when you're at normal temperatures. So, or perhaps it's stuck in the liquid, such as water. Yeah, the organic acids and phenols, they're all floating around in this sort of watery matrix. And that's what PyroAg is, except we take a little bit further, we test it and we blend it to make sure we're giving a consistent product. We also remove tars, which, as you can imagine, can cause havoc with farmers' spray equipment.
Wood vinegar is also used as a food additive, is it not, for a smoky flavour?
It is. Ours isn't, because we haven't spent the time to and the money to have it registered as such. But yes, it is. So that's right. If your barbecue chips and your barbecue sauce, it's wood vinegar you're tasting right there.
For context sake as well, I'd like to know a little bit about the relationship between PyroAg and biocarbon with your friend Chad Shepherd, as you mentioned earlier. Tell me, is there a lot of crossover in terms of people and IP between those two organisations?
There sure is, yeah. So Chad and I are directors of both companies. Biocarbon is the business that owns the pyrolysis plant, and it also owns the IP around the Steelworks coat replacement product. PyroAg is the business that sells and markets the pyroligneous acid, or the PyroAg, and char to the agriculture sector. PyroAg is really facing that agricultural market and selling into it. Those two businesses are really symbiotic. They really need each other to be successful. You need the technology to produce the products, but we can't develop the technology until we have a market demand to sell those products. So without both of those, the business doesn't really exist.
I read on your website that you were the lead on designing and fabricating the pyrolyzer. Yep. I'd like to know, without getting too engineering detail heavy, as you know, not all our listeners, and certainly not the host of this program, technical by nature. What are the challenges and design considerations to building a pyrolyzing machine that works, perhaps with a bit of context with some of the things you mentioned before about time in the machine, heats, etc.? Yeah,
that's a good question. I have to laugh at lead designer, though. You make me sound a bit like a rocket scientist there.
Oh, right.
yeah. I was in a team with a bunch of people and I did the drafting. It's probably more accurate description.
I see.
Anyway,
that aside.
Look, high temperatures and materials handling are really the two big issues in pyrolysis. So, the high temperatures obviously cause havoc with metals, and the materials handling in that hot zone and just handling the biomass is a tricky thing in itself. The high temperature stuff can be solved with expensive materials, but that makes projects uneconomical. So we've bent and broken plenty of components in the hot zone, but we think now we've got a solution which is nice and simple and reliable and based on some pretty robust technology. Materials handling is a real headache with biomass because it's never uniform in size, it's never uniform in weight, and it's never uniform in strength. Whatever you put in there is different. You can imagine a handful of wood chips. No two wood chips look the same. So moving them around and transporting them and putting them through a hot area is tricky. We've spent a lot of time on finding out what works there, and we've got quite a depth of knowledge on that now, and we're about to incorporate it into our new pilot plant, which we're really excited about.
We had this opportunity to speak because you put out a statement this week. It was about the results of a recent 4-year study involving your wood vinegar and its benefits for soil microbial activity. What's the current sort of commercial case and the scientific data supporting the wood vinegar in light of the current high fertilizer prices? Walk us through how things could stack up possibly and some of the evidence that was uncovered, please.
Yeah, okay, so I'll just run through what we did with the University of Newcastle. First of all, we really wanted to make sure that it was safe. Despite the fact that we've seen in Asia that it's been used for a long time, we wanted to make sure that in our context it would be safe and that we had some real strong evidence behind us before we started pushing this stuff out into the market. And what they did for us was they tested it against a range of organisms such as worms and fleas and plants and all sorts of weird and wonderful things. And they found no adverse reactions when used at the normal rates. In fact, it was safe up into much wider ranges than we recommend to use it in. And they really pull those organisms apart to make sure there's no adverse effect right down to the cellular level, and they say, well, there's no tumours and all this sort of stuff. So we're really happy with that, and they produced a peer-reviewed paper on it, and that got published, and so we felt much more confident there with that. Then they produced another paper on the effect of the PyroAg on plant growth promoting bacteria, and that was a big eye-opener for us in that it showed that the diversity in the number of the bacteria, those good bacteria, increased with the use of PyroAg. So we were really thrilled about that. Obviously, that's important because, as you can imagine, with a name like plant growth promoting bacteria, these are the guys that help the plants, and they basically convert and transport the nutrients in the soil to the plant. Yep. So that was a really, really important thing. Those bacteria down there and all other microbes that are in there form a complex, really complex series of relationships, which agricultural science is really only just starting to uncover, and they're not very well understood. But we know that a bigger and more diverse community of those microbes can be of great benefit. Is of great benefit, really. If they can convert your inputs more efficiently and effectively, then obviously you can use less of those inputs. And with the prices the way they are at the moment, that's going to be a big cost saving to anyone. Farmers are having a pretty good year at the moment with all this rain, and they'll get some good yields, but fertiliser and chemical prices are soaring. I mean, they've doubled and tripled recently, some of those prices, and that's if and when you can get them. So they're under a lot of pressure. So if we can reduce those just by a little bit, we're going to help them a lot. PyroAg, we spray it out there it's literally cents per hectare, but the inputs like the fertiliser in terms of $1 per hectare. So for a little outlay, they can save quite a lot of money. We've got a lot of farmers who've come back to us for several years now with this same sort of story that they're squirting out a little bit of our stuff and not having to outlay quite so much on their inputs, which is a big story. Often some of those guys, it takes a bad year or two for the farmers to sort of look around for something new, and when they come to us, not often, they tend to stick with us after that. When it's properly supported with good knowledge, the PyroAg, people stick with it, and it's a good product.
You've had some positive results with an almond farmer, I understand.
Yeah, almond farmers amongst other things. I have to be a little bit careful because I can't claim too much because we haven't registered these products.
Quite all right.
With the APVMA, but they're using it. They're getting better yields. They're getting better nuts. It just is a positive story for them. I mean, I have to say it's in combination with other methods as well. They're not just putting our stuff out and nothing else. They have to have a slight change of mindset and get some really good advice around how they're running their place.
It's another tool for the job, and not one tool does everything.
Exactly, it's another tool in the kit.
I'd like to know, please, one of the enduring issues with manufacturing in Australia is collaboration with public researchers. Not every company needs to do it, but for a company that's doing something new especially, it's often a good idea to prove the work out, to have a body of evidence behind it as you're assembling. I'd like to know, please, you've worked through the CSIRO Innovation Connections program, and you've had the involvement of New South Wales DPI for tech voucher funding, and you've made use of some programs. What's been your experience of them, and what can they offer manufacturers to link with researchers, and what, if anything, could be done better through those?
Yeah, that's a good question. We've had a really positive experience through it, and obviously we've been with the University of Newcastle. They've given us those 2 or 3 studies that have really helped us out. Those guys getting into universities, obviously they just have some expertise to do things that we just can't. I mean, there's no way we could have tested our product against all those crazy fleas and things. It's like going to see a good professional, an accountant or a lawyer or whatever. They just know what to do where you don't, and it's a tremendous benefit. Also, we learnt a lot from them. You know, with their expertise, our sort of layman understanding of the soil science for PyroAg really blossomed, and that's been a tremendous boon as well. With what they could do better, I'm not sure. I think they do really well. They have these things set up, and they have guys to advise and help you facilitate the process. I mean, we've got a guy named Dave Fleming from Oz Industry who I think was appointed as part of the CSIRO thing. And he helps just guide you through the process, which makes it a lot easier. Just having people here who know their way around that process and that bureaucracy really help, and means we don't have to learn the ins and outs of that whole system. So I think that's a great thing, the way they do that. Possibly the only thing I could think that they could do better is to get the word out to people. We didn't really know that this money and this assistance was available until we started knocking on doors about to do research. So yeah, we found it a really positive thing, I've got to say.
As you mentioned, sometimes you just don't know where to go, and I imagine an issue for a lot of smaller businesses is just, simply finding the front door for some of these research institutes, and I guess you got a hand there.
Yeah, that's right. It certainly does. And not necessarily, I mean, the researchers are easy to find because you can find your local university without too much trouble, but finding your way around that bureaucracy, it is really helpful to have those facilitator types like Dave who do help. They basically do all the work. They send you a form, you tell you to fill it in, and then they put it in the right mailboxes. It's really useful.
Let's return to your old mate, Chad Shepherd, who is also a colleague at Biocarbon, as you mentioned. The beginning of the year, we had a bit of a chat with Chad about a fascinating project. You got an exhilarating commercialisation grant for working with Molycop on biochar as a substitute for coking coal in electric arc furnace steelmaking. It's a really cool bit of work, something that could provide an answer to the scale issues of biochar, which is, sort of made in boutique amounts. And if you could get the volumes up, maybe to become more economical for everyone else. And aside from that, it's an interesting solution. Everyone wants to see carbon taken out of steelmaking, and this is one perhaps answer in that. Tell me about the progress of that work so far, if you're able to, and what's come out of it.
We're really excited about this project. As you said, steel making produces a lot of the world's CO2, and decarbonising the steel industry is really going to be necessary to get our carbon emissions down. But anyway, back to the project. We've made the first large batch of briquettes, which have gone up to Molycop in Newcastle. They'll be testing them in their furnace in the very near future. They plan to ramp up the percentage of our bricks blended with the standard coat. So they'll start with, maybe 20% of our briquettes and 80% coat until they get to 100%. We're trialling a range of different bricks, different binders to see what works best and has the lowest production cost. It's obviously still ongoing, but we're really confident that there's a solution there. We don't expect to find any problems with what we've sent them. So it's really exciting. While we're doing all that, we're busy when we're making more bricks, and now obviously knocking those out while they're testing the lot we've sent them, because they wanted, I think it was 50 tonne. So we're we're busy making 50-ton bricks.
I bet.
We've also been, just on that project, we've been approached by steelmakers overseas who want to trial the bricks as well. So we've signed an NDA with one and intend to send them a container load of bricks later this year once we've supplied Molycop for their trial. And you can imagine steelmaking is just an enormous market for this. Molycop are the smallest in Australia, and their requirements would easily underwrite a decent-sized pyrolysis plant. And then you go again, think bigger again. Australia really, it's a minnow in the steelmaking world. The overseas market is just mind-boggling when you sit down and do some numbers.
I mentioned biochar. It's very interesting, but the economics aren't really in favour of it at the moment for many applications, owing to the small volumes and high costs, and there's a relationship between the two. I was wondering if I could get your point of view, please, being intimately involved in the production of biochar, how you see the economics of it changing. What would need to happen for it to be more viable in, say, broadacre farming or any agricultural application you can think of?
That's a great question. You've done some good research here, mate.
Oh, thank you.
From biocarbon's point of view, we actually couldn't agree more that the price now is too high, and the scale of production isn't there to support a consistent price either. It really is a sort of a village size industry, cottage industry, and it needs to be taken to the next level. The high capital cost and high labour inputs of all the sort of current technologies just make it too expensive. There's nothing. We've done a pretty big review of technologies out there, and there's just nothing with the required scale to get the char cost down to the level that we think it should be at. Our other project at the moment, aside from the briquettes and selling as much wood vinegar as we can, is another pilot plant that uses a sort of a simplified design which should be much cheaper to manufacture and, most critically, easy to scale. So we're pushing ahead with that at the moment as well. The other thing happening, which is interesting in terms of the price of the char, is that in Europe they're trading a thing called a cork, or it's a CO2 removal certificate. Mm-hmm. These certificates, as the name suggests, are for removing CO2 from the atmosphere and locking it up for a period of time. So you enter this market and say, well, I'm going to take a ton of CO2 out of the atmosphere, and it's going to be for 100 years or 5 minutes or whatever. And they are being traded right now in Europe. We've teamed up with a guy named Philip Link from Link Energy, and he's going to be selling our corks for us once we're selling biochar. And of course, these things will subsidise the price of the char to some extent. The issue, of course, is like anything traded on the exchange, the price can vary a little bit. We're worried about the volatility, and there isn't much of a history yet of them being there. So we and others are wary of building a business case around that revenue stream, especially when you're going to go out and spend a couple of $1 million. So I think at the end of the day, to get the cost down, it's really going to be that old story of getting to scale. And that's part of the reason we've gone down the steelworks route, actually, is they need sizable volumes to produce steel. So you can go and underwrite an investment based on those volumes. And then with what's left over, if you make a machine that's 20% bigger, let's say, you can start to seed that agricultural market at a good price because you've got the scale already.
Understood. That's why I'm so interested in what you're doing around volume. I think that it's a piece of the puzzle that's been missing, and luck building that volume and getting the price down.
Yeah, volume's the key.
Yep.
No doubt.
It's a little bit of a change of gears, but towards the end of these interviews, I like to ask guests for their point of view on why we need a strong manufacturing ecosystem in Australia. Why do people like you and me care so much about this? Why is it worth doing? You're running a couple of manufacturing companies, and I'm obviously keen on your perspective. What is it, please?
Yeah, mate, we should talk more. I bore my wife and anyone else who listens on this topic. No one ever asked me this question.
Same with my wife.
Look, I just look at our place in the world, and strategically we're a big empty island miles from the rest of these sort of well-established democratic nations that make the world a safe place. And if we can't manufacture, grow and dig up most of what we need, well, anyone with a half-decent navy can just cut us off. You know, we saw it during COVID when other countries put themselves first and we nearly ran out of things like AdBlue. Why the hell are we not manufacturing that here? I don't know. And we're still seeing the tail effects of that now. there's all sorts of bits and pieces that we're having trouble getting, particularly in the fabrication game. A lot of the more exotic metals are really hard to get our hands on. Look, I don't particularly like tariffs and subsidies, but it strikes me that when our government buys cars and ships and trains from overseas, there's just a whole lot of tax revenue that goes offshore, doesn't get generated and reinvested here. You know, if the government spends $100 here, it probably gets upwards of $30 back in the tax. If they spend that overseas, it's gone. And I can't believe that the federal government couldn't rebate that to the states. I mean, the states do most of the spending. And if they could do that, I think it would really change things.
Lastly, is there anything you'd like to plug while you're on the line? Floor's all yours.
Oh, right. Well, look, we've got plenty of capacity in our machine shop. So if any of the listeners want to Google Daltex, it's like Caltex, but with a D. And we'll be ready and willing.
Well, John Mellows, thanks very much for your time, and it was a pleasure to speak to you here on AU Manufacturing Conversations.
Thanks very much, Brent. It was good to come on, and you've obviously done your research. It's a pleasure to talk to you.
I do my best, and pleasure's all mine. Thank you.
Thanks, mate.